Hello everybody. Today we are going to cover the composition of functions or the composite functions. So the composition of the function f with g is denoted by f of g and is defined by the equation f of g of x equals f of g of x. So let's look at this picture. So input x into the function g, then the output is g of x. Okay. Then in the second step, input g of x into another function f. So the output is f of g of x. That is the composite function f of g of x. And the domain of the composite function f of g is the set of all x's that x should be in the domain of g, and also the inner function g of x is in the domain of f. Okay. So let's look at some examples to find the composite functions and also find the domain of the composite functions. So consider the functions f of x equals 3 over x plus 1, and another function g of x equals x over x minus 2. So we know that these two functions are rational functions. So we are going to find f of g of x. By definition, we know that f of g of x is f of g of x. That means we need to input the function g of x into the function f. So f of g of x is x over x minus 2. This means we are inputting x over x minus 2 into the function f. That means wherever x comes in the function, we have to input x over x minus 2. Okay. So consider the function f of x. So instead of x, we are substituting this value. So 3 over, instead of x, we are writing x over x minus 2 plus 1. And when you look at this function, you can see that this is a complex fraction. This expression is a complex fraction. So to simplify the complex fraction, one of the methods is to find the denominator for all the denominator in this expression and multiply all the terms in the numerator and denominator by the LCD. That's the lowest common denominator. In this case, you can see that x minus 2 is the LCD. So multiply each of the terms in the numerator and the denominator by x minus 2. Okay. So 3 times x minus 2 divided by, we can cancel these x minus 2. So x plus x minus 2. So we'll get 3 times x minus 2 over 2x minus 2, or in factored form, we can rewrite this as f of g of x equals 3 times x minus 2 divided by, we can factor out 2 from the denominator, 2 times x minus 1. So that is our f of g of x. Now let's find the domain of this composite function. So we have already found f of g of x, that is 3 times x minus 2 over 2 times x minus 1. So to find the domain of f of g of x, first we need to find the domain of the inner function, that is g of x. So we know that g of x equals x over x minus 2. This is a rational function. So to find the domain of a rational function, set the denominator to 0. So x minus 2 equals 0. So from that, we'll get x equals 2. So the domain of g of x is all real numbers except x equals 2. In other words, we need to exclude 2 from the domain of g of x because x minus 2 makes the function g of x undefined. So by using the interval notation, we can write the domain of g as parenthesis negative infinity to 2, then a parenthesis union, parenthesis 2 to infinity, then a parenthesis. So we cannot have 2 in the domain of g because 2 makes the function undefined. So we found the domain of g. Now our main objective is to find the domain of the composite function f of g of x. So the next step is to exclude from the domain of g. We need to exclude from this domain all values of x for which g of x is not in the domain of f. So when you look at the composite function f of g of x, we can see that it is 3 times x minus 2 over 2 times x minus 1. So when you look at this function, we can see that this is again a rational function. We cannot have x equals 1 in the domain of this function, right? Because that value makes this composite function undefined. So we need to exclude 1 from the domain of g. So we need to exclude all values of x. In this case, the value of x is 1. We need to exclude that value from the domain of g. So when we exclude that value from the domain of g, then the domain of the composite function is negative infinity to 1, right? We need to exclude this value also from the domain of g. So the final answer for the domain of f of g of x is negative infinity to 1 union 1 to 2, right? All these numbers are parentheses because these numbers are not included in the domain, then 2 to infinity. So the domain of f of g of x equals negative infinity to 1 union 1 to 2 union 2 to infinity. You can see that all these numbers are parentheses because these numbers are not included in the domain of f of g of x. Again, in the last example, we found f of g of x, and also we found the domain of that composite function. So we can consider the same functions. F of x equals 3 over x plus 1 and g of x equals x over x minus 2. Let's find g of f of x and also the domain of g of f of x. So to find g of f of x, we need to input the function f of x into the function g. So the outer function is g. We need to input f of x into g. That is g of f of x. The function is 3 over x plus 1. So wherever x comes in the function g, we need to replace that x by 3 over x plus 1. So this is our function g of x. So instead of x, we can write 3 over x plus 1 over then 3 over x plus 1. We replace this x also by 3 over x plus 1 minus 2. And again, you can see that this is a complex fraction. To simplify the complex fraction, we need to find the LCD. So the denominator of this expression is x plus 1. This is x plus 1 and the denominator of this is 1. So the LCD is x plus 1. We need to multiply each of the terms in this complex fraction by x plus 1. So x plus 1 and x plus 1 will cancel. Here also x plus 1 and x plus 1 will cancel. Then we have 3 over 3 minus 2 times x plus 1. That is 3 over 3 minus, we can distribute this negative 2 over these terms, then we will get negative 2x minus 2. That is 3 over negative 2x plus 1. So we have 3 over negative 2x plus 1. Okay. 3 over negative 2x plus 1. So that is our g of f of x. And let's look at the domain of this function. So we have already found g of f of x. That is 3 over 1 minus 2x. Then to find the domain of g of f of x, first we need to find the domain of the inner function, that is f of x, correct? So to find the domain of f, we know that f of x equals 3 over x plus 1. This is again a rational function. So denominator should not be equal to 0. To find the domain of this, set the denominator to 0, find the value of x, that is negative 1. We know that negative 1 makes this denominator 0, so we need to exclude negative 1. So the domain of f is negative infinity to negative 1 union negative 1 to infinity. So we use parenthesis for negative 1 because we need to exclude that value from the domain of f. Now, the second step is to exclude from the domain of f all values of x for which f of x is not in the domain of g. Okay, so we found the composite function g of f of x as 3 over 1 minus 2x. That's what we found out, right? Then look at this function. what are the x values we need to exclude from the domain of this composite function? So again, you can see that this is a rational function. So set the denominator to 0. 1 minus 2x equals 0. So 2x equals 1. So x equals divide both sides by 2, 1/2. So we found the domain of f. We need to exclude 1/2 from this domain to find the domain of g of f of x. So we need to exclude from the domain of this function all values of x for which this f of x is not in the domain of g. So we need to pull out 1/2 from the domain of f. Okay. So the domain of g of f of x equals negative infinity to -1. When you look at this number line, it is from negative infinity to -1. We exclude this -1. Then -1 to 1/2. We need to exclude that 1/2 also. And then 1/2 to infinity. So the final answer for the domain of g of f of x equals negative infinity to -1 union -1 to 1/2 union 1/2 to infinity. And you can see that all these points are excluded from the domain. So we use the parenthesis. Hope you understood this concept. Let's start with another lesson next day. Okay.